All right, this video is on proportional relationships with graphs. We're going to look at the graphs. Remember, on the EOG, you have to be able to pick them from equations, tables, which is what we just did yesterday, and then graphs. So let's look at this one. Isabella walks to work each morning. It takes her 5 minutes to travel 1 city block. Sketch a graph to show the number of blocks Isabella can travel in a specific time. What's the unit rate for this graph? 5 minutes. So in a 5-minute time, she walked 1 block, right? In 10 minutes, she would walk how many? 2. All right, so let's do that. So we got minutes and blocks. So 5 minutes, she walked 1 block. 10 minutes, she walked 2 blocks. 15 minutes, she walks. In 15 minutes, she walks 3 blocks. So 15, she walks 3. 20, she walks 4, and so on and so on. And to be able to pick constant of proportionality out of graphs, they have to go through 0, 0. This is why I wanted y'all to get something where you could draw a line. And remember, I said yesterday, it goes, not only is it a straight line, but this point right here is 0, 0. Okay? So if any other line, any other way, and we've got a sheet that's on non-proportional that we'll get to next week. So determine the graph, what you do 1 divided by 5. So the unit rate for that would be 1/5, actually. So at 1, it would be 1/5. All right, so let's move on to this next graph. Use the formula, we'll do that next. The line always passes through the origin, which is 0, 0. The rate of change will be equal to the constant. Remember, we said that before, the constant of proportionality. The rate of change, the unit rate, and constant of proportionality and direct variation are the same. Okay? They're the same. So the equation of the line will be, so let's go over here and pick it. And remember, I told you to, and some of y'all didn't, I noticed on something, you didn't pick a point. Remember, I said a point. You wanted it to be like right there on the point. If we did y divided by x here, what is y here? 1. What is x? So what's the rate of change here? 1. So, Vicente, since you're going so well, what's the equation for this graph? Y equals 1x, or you could just put y equals x. You're going to get the same thing. Because a variable by itself is understood to be 1. Okay? All right, let's go down here and look at this next one. An ATV travels 25 miles each hour, where x is the number of hours and y is the total miles. Now, it just said in 1 hour, he went how far? 25 miles. All right, so 1, he went 25. 2, he goes 50. 3, he goes 75. 4, he goes 100. Does anybody not understand how we got those numbers? Does anybody not understand? Can somebody, what's the rate of change? Y divided by x. So find a y and then divide it by x. What? 25. The rate of change is 25. And then the equation would be y equals 25x. Very good. So 25 times 1 is 25. 25 times 2 is 50. 25 times 3 is 75. 25 times 4 is 100. 25 times 5 is 125, and so on and so forth. And once again, it has to be a straight line going through the origin every time. and this is the origin. You might have graphs that are just this one quadrant, or you might have a whole graph, okay? All right, let's slide over here to 2. The number of cars X is proportional to the number of wheels Y. How would we do that? Start with 1. Exactly. And how many wheels you got with 1? 1 car. How many wheels? 4. Very good. So we can do that. So knowing what we know right now, before we go any further, what's the rate of change? 4. Equation?
Y equals 4x.
Very good. Y equals 4x. Knowing that, 2 is 8. 3 is 12. Okay, so we'll stop there. And then remember, it's got to go through the origin. I know this magic marker bleeds, but. All right, I'll give y'all a second to catch up. All right, and this last one at the bottom here, Sandra plots the points at 0, 0, and 5, 10 on a graph to represent a proportional relationship. And what I did was I made this right here, just right quick. And she plotted at 0, 0, right? Which is right there. And then she plotted at 5 and 10. Hopefully it'll go up 10. Okay, I'm going to count these going up by 2. 4, 5, and then 2, 4, 6, 8, and 10. So this is 10, and this is 5, right? And I'm going to draw a line. Do we have what we need to know what the rate of change is? Because we have, very good, I think that was you, Zaylin. So if we take y and divide it by x, and our y is 10, and our x is 5, our rate of change is 2. Very good. And I'm going to lay this right here. So in the equation, y equals 2x. So if I went to 10, my x is 10, my y is what? If my x is 10, my y is what?
2. 5.
If my x is 10,
Oh.
if my x is 10, what's my y? 20. Yeah, whoever said that. Very good. Remember, when your x, you just plug in, okay? Let's flip that out. Is that the only page? Oh, that was quick. Okay. So let me